Okay, so in this video, we'll be going over Unit 1, Lesson 5, the size of the scale factor. The goal of this lesson is to understand and explain how the scale factors of 1, less than 1, and greater than 1 affect the size of copies. We also have to understand and explain how the scale factor between figure A and figure B relates to the scale factor between figure B and figure A. So switching and flipping reciprocal, that's something we're going to be covering later on in the lesson also. So keep in mind. Learning target is to be able to describe the effect on a scaled copy when I use a scale factor that is greater than 1, less than 1, or equal to 1. I can also explain how the scale factor takes one figure, figure A, to the copy, figure B, as it relates to figure B and figure A. So just being able to explain how the reciprocal works with figure A and B. And also being able, the first target, being able to understand that when we have a scale factor that is greater than 1, our figure should increase in size or does increase in size. When it is less than 1, so a decimal or a fraction, the shape or figure will decrease in size. And when it's equal to 1, the figure or shape will remain the same size. Okay, so we'll touch on that later on. And again, we're still doing the same Common Core State Standard, solving problems involving scale drawings of geometric figures. So in the do now, the warm-up activity, we saw, or we were asked to find x, the variable, the unknown. So here we have two fractions. 1/5, x equals to 1. And again, when we have 1 as our answer, when we're multiplying fractions, we practice that when you multiply that fraction by its reciprocal, your answer will always be 1. So this is the purpose of these two activities. So we multiply 1/5 by 5 over 1, and that should give us 1, because 1 times 5 is 5, and we get that in the denominator and the numerator, and we reduce that to 1. And in the second example, we see that 2/5, when the reciprocal is multiplied, 5 over 2, we get 10 over 10, and we could reduce that to be 1 also. So those are, or that was the purpose of that warm-up activity. It's given us practice on multiplying reciprocal fractions, because when we multiply this fraction 1/5 by a larger number, greater than 1, that increased the fraction. And when we multiplied 2/5 by 5 over 2, that gave us 1 also. And again, 5 over 2 reduces to 2.5. But when we multiply those, we got 1. Okay, so we'll move on to the activity. So we were looking at scaled figures. In this activity, it says your teacher will give you a set of scale cards in each figure. Figure A is the original and figure B is the scaled copy. So again, giving us practice on multiplying our reciprocal fractions and practice between scaling our smaller figure to a larger and a larger figure to a smaller, and back and forth. Okay, so this was it's an example of some of the figures we had to scale. So we see here, I just get my, we had to count the units, 1, 2, to get our scale factor. So this size measured 2 units vertically, 1, 2, 3 units horizontally, and we count the same corresponding sides on figure B, the copy, and we had 4, and we have 1, 2, 3, 4, 5, 6. So smaller figure A we see is getting larger, so we know we're going to multiply this figure by a number larger than 1. We had 2 in our denominator and 4 in our 1, 2, 3, 4. Yeah, so we have 4 over 2, and that reduces to 2. Or if we use our horizontal plane, 1, 2, 3, 4, 5, 6. So we'll have 6 in our numerator, and then we'll have 3 in our denominator, and that also reduces to 2. So that is some practice on some of the shapes that we worked on in class. Let me just scroll this up. We also practice on the circle. So 1, 2 units across the diameter. And in figure B, the copy, 1, 2, 3, 4, 5, 6. 6 in the diameter of figure B, the copy. And when we make that into a fraction, 6 over 2, we can multiply 2 times 3. We see that our scale factor here is 3. And if we were to reduce, or sorry, if we were to do the reciprocal and find out the scale factor from figure B to figure A, we would do the reverse, and we would have 6 in our numerator, 2 in our, 6 in our denominator, A, 2 in our numerator, and that would reduce to 1/3. So that 3 over 1 scale factor that gave us A to B, the reciprocal is 1/3, 1 over 3. So that's how we figured out the reciprocal scale factor for this particular figure. So if we move on, we're supposed to arrange the scale factors for these figures in order. Once we figured out the scale factors for all of them, and in my notes, once we did that, we see that scale factor of 2 were for the first and the 9th card, scale factor of a half, 3rd, 7, and card 11. Scale factor 3, cards 2, 5, and 10. Scale factors for a 3rd were cards 4, 6, and 13. And card 1, scale factor of 1 for cards 8 and 12. So we would put that in this box once we arrange that. And you would explain, you know this because after comparing corresponding sides, you were able to multiply the scale, or you're able to reduce the fraction once you arrange them in order of numerator and denominator from big to small and small to big. You're able to multiply that, divide that, and get the reciprocal of that fraction in order to reverse the figure. And remember, we're multiplying by a number larger than 1 to increase our shape or figure, and we're multiplying by a number less than 1 to reduce that shape. And of course, we're multiplying by a scale factor of 1 to keep that figure the same size. Okay, so if you look at cards 10 and 13, you'll see that cards 10 is increasing in size, so that scale factor is going to increase, and we said that scale factor was 3. And if you look at cards 13, that figure is decreasing in size, so that's why that scale factor is a 3rd, the reciprocal. They also asked us to look at card 8 and 12. If we look at 8 and 12, we see 12 the same shape. We'd count the diameter. We can also count the angles at a side and see that they're corresponding in length. If we look at card 8, eight's right here. So we look at cards 8, we count the sides, 1, 2, 1, 2. We see that they have corresponding lengths. So that's what we're supposed to notice for this, and we would explain that because we counted the corresponding sides. They have the same measurement. When sides have the same measurement, 2 over 2 reduces to 1, so we have a scale factor of 1. So we move on to the next section. What is the scale factor from the original triangle to its copy? So we see the original has 5 sides, 1, 2, 3, 4, 5, And to the copy is smaller. So we know our scale factor is going to be less than 1 a fraction. So we put our original in the denominator and our copy in the numerator in this example. And that fraction is 1/5. So that is going to be the scale factor for our first question. What is the scale factor? And I can explain that because I counted the corresponding sides. And the fraction 1/5 was the corresponding measurement. In my copy, I had corresponding measurements of 1 in my side measurements, and my original had 5. So 1/5 is my scale factor. And if I were to do the reciprocal of 1/5, that would give me 5, and that would take my copy into a larger figure. And that number 5 is again larger than 1. And that's what we're looking for when we're increasing our size and our shape. And number 1, in this example, we're supposed to draw our scale factor, the copy, and we're given a scale factor of 2. So we have 4. So count 4, and then I have 2 on the 1 on the top. Multiply that by 2. That should give me my 2. And I have 2 on the sides. I multiply by 2. Should get 4. And it's 4. 1, 2, 3, 4, 1, 2. So this is how I get that figure. And for this example, we see that we have a scale factor of essentially a half, because 3/3 is 1.5. And since we have 3 units on this top measurement, we can't be fooled, because 1, 2, 3. And if we're going to reduce that by half, essentially, we're going to be reducing only 1 of our unit because we're increasing that by half. So since our original figure started with 2 sides, and we're increasing that by half of 2 is 1. So we're going to add 1 side because half of our original side is 2. Okay, so reason your shape is going to be 2, because they said we are increasing everything by half. So once we count the sides, we will see that 4, 4 is going to be 2, 2. Oop, let me redo that one. 2. So your original should look like that. 2, half of 2 is 1. So that's why we're going to add 1 to each side in this copy. Okay. All right. And as we move on, what is the scale factor? This original figure, we can see that the side unit measurements are all corresponding. So these units equal 1. So this is a scale factor of 1, because you can see the side measurements are all the same. As we move on, we have to increase this figure by 3. So we would measure this with a ruler or index card or something that can keep consistent measurement. And this number 4 should originally be, or the copy should be 3 times larger than the original. Okay, so are you ready for more? Is what we're going to tackle a little later on in the unit. Lesson summary: the size of the scale factor affects the size of the copy. When a figure is a scale copy by a scale factor greater than 1, the copy is larger than the original. When the scale factor is less than 1, the copy is smaller, so a fraction. When the scale factor is exactly 1, the copy is the same size as the original. So in this triangle, we see our shape is increasing, again, by half, right? Half of 5 is 2.5. So this measurement is 2.5. Half of 3 is 1.5. So 4.5. Half of 4 is 2. So this is why these measurements are 2. We are given the under the assumption that these figures are corresponding angles. So corresponding angles, same shape, corresponding sides, right? So they're not distorted in any way. And we have produced a scale copy. Now to go from a larger figure to a smaller figure, we do the reciprocal of 3/2. And that's going to give us 2/3. And essentially, that gives us our smaller figure. Okay. So finish this up, turn this in, and if you have any questions, comment on Google Classroom. Thank you and good night.